So right now we can integrate any polynomial, because by the power rule we can integrate any term of the form x to the n, and combining that with what we just did for the x to the minus 1, we can get anything that looks like that. We can integrate any polynomial, because just by linearity and stuff like that. Let's think of what other functions we might want to find their antiderivatives. So the next class that we're going to talk about, let's talk about our trig functions here. So I just wrote down a chart of 6 trig integrals here, but these are all ones that you should already know here, because this is just undoing all of the differentiation rules that we learned back in chapter 3 about trig function. So what's the integral of sine x? Well, let's think to ourselves. What function, when we take the derivative of it, gives us sine x? Well, taking the derivative of cosine x will give us minus sine x. So taking the derivative minus cosine x will give us minus sine x, which is plus sine x. So the antiderivative of sine x is minus cosine x plus c. What function's derivative is cosine x? Well, that's sine x. So the antiderivative of cosine x is sine x plus c. Undoing the derivative rule for tangent gives us the antiderivative of secant square x is equal to tangent x plus c. And there's 3 more rules here that you are very capable of reading for yourself. So the point here is these should not be difficult to learn, because these are just ones that we're just undoing our derivative rules. And we know our derivative rules, this is just applying them in reverse. Okay, what other functions should we think about? Well, how about exponential functions? We know that the derivative of e to the x is equal to e to the x. And also, we know the derivative of e to the kx, where k is a constant, is k times e to the kx. So, translating this into an indefinite integral, the antiderivative of e to the x is just e to the x plus c, because the derivative of this is equal to this. Now, to do this one, it requires just a little bit of thought here. The integral of e to the kx dx. So when we take the derivative here, when we take the derivative of e to the kx, it spits out a factor of k here, and we don't want there to be a factor of k over here. So what do? We put a factor of 1 over k here. So we take the derivative of this, we get k times 1 over k e to the kx. We get e to the kx here. So this gives us a